Next, we're gonna talk about solving system of linear equations. Solving system of linear equations. We learned this in Math 137, but I can quickly review using this example. Okay, so let me copy this question down here. So we are given two equations, 3x plus 2y equals 19 and x plus y is equal to 8. We call this as a system of linear equation because we have two or more linear equations, right? So we call that system because we are using the same system, same coordinate. And when I ask you to solve the system of linear equations, meaning you need to find x value and y value that works for both equations. So basically, we're talking about the point. There is a certain point that works for this equation and that equation. That point that is on this line and that line. Most of the linear equations have at least one point, but not always. Sometimes there is no point when they are parallel, they don't meet, right? So there is a zero solution. Most of the time they meet at one point. It doesn't have to be they are perpendicular. Sometimes they are not perpendicular, but they meet at one point, right? So in that case, there is one solution. Sometimes there are infinitely many solutions. When two graphs are exactly the same, two equations are exactly the same, there are infinitely many solutions, right? So there are three different cases. And going back here, how do we solve the equations? We have several ways to solve the solutions. One, we can use the graph and find that point that two graphs are meeting. But this has to be very precise to find the exact point. If you just approximate the graph or you don't use the ruler like I do, then you can eyeball the point. You can approximate the answer, but not exact. So be careful, okay? Two, you can use substitution method. Third, you can use elimination method. Okay, so briefly, let's talk about this. So if you use graph, you can solve this for y, or I told you how to graph, right? Three different ways. Either you can find the order the pairs and plot them and draw the graphs and find the intersecting point, or you can use x-intercept and y-intercept and draw the graph, so intercepts. Or three, you can use a slope intercept. Either ways, you can draw the graphs of both of the equations and find where they meet. That point should be our solution. So I will skip that part, okay? I will show you how to use substitution and elimination here. First, substitution. So our graph is 3x plus 2y. Let me just write it here. 3x plus 2y is equal to 19 and x plus y is equal to 8. Substitution, literally we are substituting something with another. So in this case, we can put this as x equals something easily or y equals something easily because both coefficient for x and y are 1. So if I rewrite this as y equals using, let's say, a and b equation, from b equation, I can rewrite this as y equals by subtracting x on both sides. And this x will be gone, right? I'm subtracting x on both sides, so I have a negative x plus 8. So using this, because b is same as this b, I just rearranged it. I can plug it in here. Instead of this y, I can substitute that y with negative x plus 8, because that point where they meet should be same for both equations. So then I have 3x plus 2 times, instead of y, I can substitute that with negative x plus 8, right? And the rest of it is equal to 19. Now I have one equation with one variable, then I can solve for x. So I have 3x plus 2 times negative x, negative 2x, and I have 2 times 8, 16 is equal to 19. Now I can combine like terms. So 3x and negative 2x, how many x's are there? 3 and negative 2, 3 minus 2, 1x, right? So 1x is same as x, plus 16, I can subtract that on both sides. So I can get rid of that, leaving only x term on the left hand side. Then right hand side is 3. So x is 3. So that's what we got for x. How do we find y? We already said that y equals negative x plus 8. So negative x plus 8. So I can substitute that x with this 3. Negative 3 plus 8, which is 5. So my x is 3 and y is 5, right? So using substitution, I found 3, 5. If you have draw a graph, two graphs for these two equations, it's gonna be about this point or exactly that point, okay? All right. The third way is elimination method. So we are eliminating one of the variable, okay? So we have 3x plus 2y equals 19 and x plus y equals 8. You can either get rid of x term or y term. To get rid of x term, I can multiply this whole thing by negative 3, because then I will have positive 3x up here and negative 3x here. So when I add them together, it will be gone, right? So that's what we're gonna do. So I'm just gonna leave the first equation, a, but I'm going to multiply b by negative 3. Okay, so a is still the same, 3x plus 2y is equal to 19. Multiply this whole equation by negative 3. Negative 3x minus 3y equals negative 24. Now I can add everything by terms. So 3x and negative 3x, it's gone, 0. 0 plus 2y minus 3y, negative 1y. This side, negative 5. So divide both by negative 1 or multiply by negative 1, then positive y. Multiply that by negative 1, then positive 5. So y is equal to 5. We found y. Then you can plug it back to either a or b. Looks like this is easier, so I'm gonna plug it in here. Okay, then we can have x plus, instead of y, we found y as 5 is equal to 8. So 1 plus 5 equals 8, 3. So x is 3, or subtract 5 on both sides, then x equals 3. So we found x and y. So our solution should be 3, 5. Okay, so that works. That is elimination method. Okay, and you're gonna be given more example problems to do all that. And I have step-by-step work here, so take a look at your notes. Okay, all right. So we are done with this, and I have another example here. Please solve this system of equation using graph substitution and elimination method, and the solution for that should be 1, negative 2. If we have a question for that, please let me know. Okay? Okay. Now, let's talk about number of solutions. I already talked about this, right? So we can have 3 cases. No solution between 2 lines. So when they have no solution, when 2 graphs are parallel, right? So you can connect it. When do they have 1 solution? When they intersect at exactly 1 point. How about infinitely many solutions when the two equations are exactly the same line, right? Okay. What's next? So we got that idea. Okay, and I have more examples there. So I want you to solve them, okay? Then you will find it out has no solution because they are parallel. So you want me to take a look at that? Okay, let's see. What were they? Okay, so if you are given, where's my cursor? Okay. Oh, what's going on here? Something's wrong. We are given two equations. So this is the system of equation because we have the same x's and same y's. Okay, we use the same x-axis and y-axis and same plane. And we can think back about how many solutions. How did we determine that? Using slope and intercept, right? So going back here, we knew that if they are parallel, there's no solution. If they have one solution, well, they meet at one point, and we can find what x and y is for that point, right? And if slope and intercept both are equal, we have infinitely many solutions. So knowing that, we can find that out how many solutions there are. Okay. So 2x minus 3y equals 1. Let's suppose that is equation A and next one is equation B. So I can rearrange these equation for slope-intercept form. Okay, so we have 2x minus 3y equals 1. I am solving for y equals mx plus b, so solving for y. So I'm going to get rid of 2x by adding negative 2x on both sides. So I have negative 3y, this is gone, right? On the left hand side, negative 3y. On the right hand side, I have a negative 2x plus 1. I can divide both sides by negative 3. So whole thing by negative 3. So I have positive 1 times y, y. I can separate this, negative 2x over negative 3 plus 1 over negative 3. Negative 2 over negative 3 is positive 2/3 x minus 1/3. Okay, so we have a slope and intercept for equation A. How about equation B? For B, we have a negative 4x plus 6y equals 5. We can solve for y again by adding 4x to get rid of it, but you need to do the same thing on both sides of the equation, so it's still balancing. Equation still works. So gone, and you have 6y equals positive 4x plus positive 5. You can divide both sides by positive 6. Whole thing by 6. So you have y. Well, we can separate these, right? So 4 over 6x plus 5/6, right? And we can simplify this. 2/3, because you can divide 4 by 2 and 6 by 2. So 2/3 x plus 5/6. Now we have both equations as mx plus b form, slope-intercept form. So we can compare the slopes. So let's compare the slopes. 2/3 and 2/3. Slopes are equal. So it can be either parallel or they can be exactly the same equation. Now let's compare the y-intercept, negative 1/3 and positive 5/6. They are not equal. These are simplified form, right? When they are simplified, they have to be equal to make this equation. But if they are different, they never meet, right? So they are parallel, and we can conclude there is no solution for this. Okay? Because they're slopes are equal, but the y-intercepts are different. So they are parallel. Okay? Alright, next question. 2x minus 3y, let's suppose that is first equation A and that's B. And let's do the same procedure. Solve for y, because we want to solve for slope-intercept form. So 2x minus 3y equals 1. I think it's still the same thing as this one. So we have y equals 2/3 x minus 1/3. 2/3 x minus 1/3 for the first equation. And the second equation is a little bit different, right? So minus 4x plus 6y equals 5 here, and it's equals negative 2. So it is slightly different. And my negative 4x plus 6y is equal to negative 2. Let's solve for y. We can add 4x on both sides of the equation, so equation doesn't change. Still equal. Minus 2, right? And divide both sides by 6. So divide the whole thing by 6, whole thing by 6. So y is equal to 4/6 x minus 2/6. We can simplify this. We always simplify to compare, okay? Because if you simplify that, you can find equivalent fraction for that. So divide both by 2 because they're even numbers. 2 divided by 2, 6 divided by 2, 4 divided by 2 is 2, 6 divided by 2 is 3. Here again, 1/3. So it is 2/3 x minus 1/3. What do you notice? They are identical, right? So the slopes are equal and y-intercepts are equal. So they are identical. Even if they look different, they are identical. So if you draw a graph, they will be exactly the same, right? So how many solutions are there then? Both are this. So all of these points on that line should be the solutions. Yes. So there will be infinitely many solutions. So all of the points on that line should be the answer.